So today we are looking at congruent and similar figures. This is lesson 06. Tomorrow we'll do 07. Thursday is a review day. The next time I see you after Wednesday will be on a Monday, and that will be your chapter 0 test. So, congruent figures are figures that have the same size and the same shape. Congruent figures are figures that have the same size and the same shape. In congruent figures, the order matters. The symbol for congruent is the equal sign with the tilde on top. Two figures are congruent if their corresponding sides and corresponding angles are congruent. Two figures are congruent if their corresponding sides and angles are congruent. Similar figures have the same shape, but are not the same size. The symbol for similar is the tilde without the equal to. Corresponding angles and their measures are congruent, while the sides are proportional. Corresponding angles are congruent, and the measures of their sides are proportional. When listing congruent statements, there are always 6 of them for a triangle. There would be 8 of them for a rectangle. So the number of sides determine the corresponding angles and sides. So if there are 3 sides, there are 6. If there are 4, there are 8. So essentially the number of sides doubles for correspondence. Let's start with our angles. So we can say angle B is congruent to angle F because they both have one arc. Angle A is congruent to angle E because they have 2 arcs. Angle C is congruent to angle D because they have 3 arcs. We can match the sides similar to the angles. When you do your sides, you want to go from like one arc to two. So maybe I'd go from angle B to angle A. If I go from 1 to 2, then over here, I also need to go from 1 to 2. So I'd say that that's congruent to FE. The line I wrote above those represents a line segment. The symbol in front of the letter is an angle. You must put your symbols when labeling segments or angles. So I went from B to A. Now I'll go A to C. So that's 2 to 3. So that's E to D. No. And last, let's go C back to B. So that would be like going from D to F. So 3 sides, 6 congruency statements. Mine probably has like a little bit of typo here. That should be a triangle, not an X. So therefore, triangle. And again, I like to go 1, 2, 3. So it would be BAC is congruent to triangle FED. And again, you got to match the angle to the right angle. So I should be able to look at the triangle congruency statements and say, okay, angle B goes to F, good. C goes to D, good, etc. So similar figures, the first thing you want to do is look at the angles. So we'll notice that both of these shapes have 90-degree angles. Therefore, the angles are congruent. So similar shapes have to have congruent angles. And then the sides need to be proportional. So what I'm going to do is compare the sides of the first rectangle. So its width is 2. Its height is 5. So we're going to compare 2/5 to the second rectangle, whose height is 16, width is 16, height is 40. So we're going to compare 2/5 to 16 over 40. If they are equal, then the rectangles are similar. So what we need to do is simplify that fraction. So 16 divides by 8. 40 divides by 8. So that fraction reduces to 2/5, which is the other side length ratio. It's already in simplified form. So 2/5 is to 2/5. Therefore, they are similar rectangles. This is all coming back to us from last year. Determine if the polygons are similar. So this is again where the angles matter. So we're going to compare the side length across from angle 35. So that's 16. And then we'll compare to the side length across from 90, which is 34. So we need that to equal side length across from 35, which is 6, to 10. So 6 and 10 both divide by 2. So you get 3/5. And we're going to compare that by dividing 16 by 2. So you get 8/17. Is 3/5 the same as 8/17? Are they the same fraction? No. So therefore, these are not similar triangles. So as long as you keep them matched up. So like I picked the 6 and 16 and the 10 and 34. You have to just keep them matched. So like I could have done the 8 and 10 to 30 over 34. Or like the 6 over 8 to 16 over 30. You just have to make sure you match them. Like I can't do 6 to 16 and 8 with 34. We can also use the idea of similar triangles to help us solve problems. So we have this city and they're trying to decide how long they need to make a bridge. So here's the bridge they're trying to just design. They want to know how long does that bridge need to be. So we are trying to determine this length right here. So we're looking for that x. So what they did was they said, okay, I can construct a triangle, and we'll call that triangle A, B, C. So they created this small triangle ABC to help them find the length of the larger triangle ADE. So we have like a triangle sitting in a triangle. If I drew those off to the side, the height of the little blue triangle is 110. Its base is 40. The orange triangle is the entire length here. So that whole length there is actually the 150 and the 110 added together. So its height is 260. And its base is the x value we're looking for. So once again, I can set up a statement of proportion to help me find my missing side. So you could say, okay, 110 over 40 equals 260 over x. Does anybody remember what the method is called that we use to like solve this? Perfect. We're going to cross multiply. So what that means is you're going to take 110 and multiply it by x and set it equal to 260 times 40. And then you're going to solve for x by dividing both sides by 110. And we get x equals 94.545. What are the units? So units are important. This is a real world word problem comparing lengths. So that means that this answer has the same units as the answers up here. So this is in